Welcome back to my video tutorial series of operating system. My name is Amit Kanskar, Faculty of Information Technology Department, Oriental College of Technology. Today in this video we will study system calls and types of system calls. System calls provides the interface between a process and operating system. These calls are generally available as assembly language instructions and are usually listed in the manuals used by assembly language programmers. Some systems may allow system calls to be made directly from higher level language program, in which case the calls normally assemble predefined functions or subroutine calls. They may generate a call to a special runtime routine that makes the system calls, or the system calls may be generated directly in line. Several languages such as C, Bliss, BCPL, Programming Language 360 and Perl have been defined to replace assembly language for system programming. These languages allow system calls to be made directly. Some Pascal systems also provide an ability to make system calls directly from Pascal program to the operating system. C and Perl implementation include directly system calls access. Most Fortran systems provide similar capabilities, often by set of library routines. Similarly, C programming language also provides these kinds of routine to make system calls. As an example of how system calls are used, consider writing a simple program to read data from one file and to copy them to another file. The first input that program will need is the names of two files, the input file and the output file. The names can be specified in many ways depending on the operating system design. One approach is for program to ask the user for the names of the two files. In an interactive system, this approach will require a sequence of system calls, first to write a prompting message on the screen and then to read from the keyboard the characters that define two files. Another approach is used for batch systems, is to specify the names of the file with control statements. In this case, there must be a mechanism for passing these parameters from the control statement to the executing program. On mouse-based and icon-based system, a menu of file names is usually displayed in a window. The user can then use the mouse to select the source name and the window can be opened for the destination name to be specified. Once the two files names are obtained, the program must open the input file and create the output file. Each of these options require another system call. There are also possible error conditions for each operation. When the program tries to open the input file, it may find that there is no file of that particular name or that the file is projected against access. In these cases, the program should print a message on the console. It is another sequence of system calls and then terminate abnormally. Again, another system call. If the input file exists, then we must create a new output file. We may find that there is already an output file with the same name. This situation may cause the program to abort a system call. Or we may delete the existing file, again another system call, and create a new one, another system call. Another option in an interactive system is to ask the user a sequence of system call to output the prompting message and to read the response from the terminal, whether to replace the existing file or to abort the program. Now that both files are set up, we enter a loop that reads from the input file, another system call, and write to the output file, again another system call. Each read and write must return status information regarding various possible error conditions. On input, the program may find that the end of the file has been reached or there was a hardware failure in the read, such as parity error. The write operation may encounter various errors depending on the output device. No more disk space, physical end of the tape, printer out of the paper, and so on. Finally, after the entire file is copied, the program may close both files. Another system calls, write a message to the console, more system calls, and finally terminate normally the last system call. As we can see, programs may make heavy use of the operating system, and there are so many system calls in this particular process. Most users never see this level of details. However, the runtime support system for most programming languages provide a much simpler interface. For example, a write statement in Pascal or Fortran or C or any kind of programming language probably is compiled into a call to a runtime support routine that issues the necessary system calls, checks for errors, and finally return to the user program. Most of the details of the operating system interface are hidden from the programmer by the compiler and by runtime support package. Most programmers do not use low-level system calls directly, but instead use an application programming interface API. The following sidebar shows the read call available in the API on Unix-based systems, as you can see in the figure. The use of APIs instead of direct system calls provides for greater program portability between different systems. The API then makes the appropriate system calls through the system call interface using a table lookup to access a specific numbered system call as shown in the figure. That is the handling of the user application invoking a open system call. Parameters are generally passed to system calls via registers, or less commonly by values pushed onto the stack. Large blocks of data are generally accessed indirectly through a memory address passed in the register or on the stack as shown in the figure, passing of parameter as a table. Now we come to the types of the system call. As you can see in the figure, there are 6 major categories and following are the 6 subsections. Those 6 major categories are process control, file management, device management, information maintenance, communications, and protection. Under process control, there are subsections like AND, abort, load, execute, create process, terminate process, get process attribute, set process attribute, wait for time, wait event, signal event, allocate, and free memory. Under the file management, subsections are create file, delete file, open, close, read, write, reposition, get file attribute, set file attribute. Under device management, subsections are request device, release device, read, write, reposition, get device attribute, set device attributes, logically attached or detached device. Under information maintenance, there are subsections like get time or date, set time or date, get system data, set system data, get process file or device attribute, set process file or device attribute. Under the communications, create, delete, communication connection, send, receive messages, transfer status information, attach or detach remote devices. Under the protection, set file security, initialize security descriptor, set security descriptor group. These are the some subsections available in the protection category. Some of the examples are shown of the Windows and Unix system calls as shown in the figure. Standard library calls may also generate system calls as shown here. Example of the standard C library. The standard C library provides a portion of the system call interface for many versions of the Unix and Linux. For example, let's assume a C program invokes the print statement. The C library intercepts this call and invokes the necessary system calls in the operating system. In this instance, the write system call, the C library takes the value written by the write and passes it back to the user program. This is shown in the figure. Now we discuss each category of system calls one by one. First of all, we discuss process control. Process control system calls include AND, abort, load, execute, create process, terminate process, get process attribute, set process attribute, wait for time or event, signal event, and allocate and free memory. Processes must be created, launched, monitored, paused, resumed, and eventually stopped. When one process pauses or stops, the another must be launched or resumed. When processes stop abnormally, it may be necessary to provide core dumps and or other diagnostic or recovery tools. Compare disk operating system DOS, a single tasking operating system, with Unix, the multitasking operating system. When a process is launched in DOS, the command interpreter first unloads and much of itself as it can to free up memory. When a process is launched in DOS, the command interpreter first unloads as much of it as it can to free up memory, then loads the process and transfers control to it. The interpreter does not resume until the process has completed, as it is shown in the figure. Because Unix is multitasking system, the command interpreter remains completely resident when executing a process, as shown in the figure. The user can switch back to the command interpreter at any time and can place the running process in the background even if it was not originally launched as a background process. In order to do this, the command interpreter first executes a fork system call, which creates a second process which is an exact duplicate or clone of a original command interpreter. The original process is known as the parent and the clone process is known as the child, with its own unique process ID and parent ID. The child process then executes an exec system calls, which replaces its code with that of the desired process. The parent command interpreter normally waits for the child to complete before issuing new command prompt, but in some cases it can also issue a new prompt right away without waiting for the child process to complete. The child is then set to be running in the background or as a background process. FreeBSD running multiple programs, as it is shown in the figure. Now we come to the file management category. The file management system calls include create file, delete file, open, close, read, write, reposition, get file attribute, and set file attribute. These operations may also be supported for directories as well as the ordinary files. Device management. Device management system calls include request device, release device, read, write, reposition, get device attribute, set device attributes, and logically attached or detached devices. Devices may be physical, for example disk drives, or virtual or abstract, for example files, partitions, and RAM disks. Some systems represent device as special files in the system so that accessing the file calls upon the appropriate device driver in the operating system. Information maintenance. Information maintenance system calls include get or set the time, date, system data, the process. Information maintenance system call include calls to get the time, set the time, get the date, set the date, get system data, set system data, get process, set process, file or device attributes. System may also provide the ability to dump memory at any time. Single step program pausing execution after each instruction and tracing the operation of a program, all of which can help to debug the program. Now we come to the communication category. Communication system calls: create communication connection, delete communication connection, send message, receive messages, transfer status information, and attach remote device or detach remote device. The message passing model must support system call, identify a remote process and or host with which to communicate, establish a connection between two processes, open and close the connection as needed, transmit messages along the connection, wait for incoming messages in either of the blocking or unblocking or non-blocking state, delete the connection when no longer needed. The shared memory model must support calls to create and access memory that is shared among processes and threads. Provide locking mechanism restricting simultaneous access, free of shared memory, and or dynamically allocate it as needed. Message passing is simpler and easier, particularly for computer communication, and is generally appropriate for a small amount of data. Shared memory is faster and is generally be a better approach where large amount of data are to be shared, particularly when most processes are reading the data rather than writing it, or at least when only one or a small number of processes need to change any given data item. Protection provides mechanism for controlling which users or processes have access to which system resources. System calls allow the access mechanism to be adjusted as needed, and for non-privileged users to be granted elevated access permission under careful controlled temporary circumstances. Once only of concern or a multi-user system, protection is now important or all systems in the age of ubiquitous network connectivity. So these were the categories of the system calls which we have studied right now. So in this video we have learnt what is system calls. We have illustrated the sequence of system calls required to copy a file, and we have discussed the types of the system calls. There are 6 major subcategories like process control, file management, device management, information maintenance, communications, and protections. Thanks for watching. See you in the next video.